I'm worried that that went by a little quickly at the end, and StatCrunch is so fast for doing this, even, way faster than Excel. So let's just go through it one more time. All right, so you click Stat, and remember StatCrunch is available under Tools for Success, just FYI. All right, you go to Proportions. This is one sample. You have a summary here. You have they gave you information. Now, I said in the last video it was 4. Now, where in the heck did I get 4 from? Well, the answer is because it was 0.05. And remember that p hat is x divided by n, right? You know that n is 80, so what you need to find x is, this is why I left that space there. See, I told you there was a method to my madness. It was 80 times 0.05, which is 4. That's where I get it from. So there were 4 African Americans in the room. Because they say it was 5%, that would be 4. If they didn't give you a whole number, if it came to like 3.8, then you'd round to 4. Out of the number of observations is the size of the jury panel, which was 80. Then I click Next. For us, the null proportion was 0.5. Right, that's P0 for us. And I had to pick the left-hand one, which I didn't at the first, but I changed. Then you go to Next. Sure, Calculate. And then you can see here, see that Z statistic right there? That's negative 8.05. It's the same one we found over here in Excel. There was 4 out of 80 total. The sample proportion, see, 0.05. That was our p hat. And then notice the p-value. When it gets really, really low, StatCrunch will just tell you it's less than 0.0001, which this 4.14e negative 16 for sure is. Okay, and remember that when you're in your Excel assignments and stuff, you can just, oopsie, cancel. I didn't mean to do that. You can just copy and paste. Boom. And there it is in Excel. Cool. Cool. All right. And I, of course, even though you can't see the formulas, it doesn't matter. I know that this came from StatCrunch, and I'm totally cool with that. All right. So there you go. That's another way to do it. You can even copy and paste it into here if you so desired. I don't, but whatever. Now I want to compare and contrast the classical and p-value methods for just a second. So classical method, let's do one thing about here. When we compare them, we're looking for the similarities, right? Okay, so some similarities. One, if you reject with one method, you're going to reject with the other, and vice versa. If you reject H naught with one method, you will also reject it with the other method, as long as it's the same data and alpha. Okay? I mean, as long as you're working with the same data set and the same alpha, then of course, when you reject with one, you'll reject the other. And that means that you can double check yourself. Like if you find the classical method easier, which nobody does, but whatever, then you can check it with the p-value and vice versa. Personally, I just think p-value is so fast and easy. Excel and StatCrunch find p-values very simply, and then you can compare. And remember, with p-value, you're always looking for low. The other thing to keep in mind is that both methods have similar graphs, but they're not the same. But they both have, they'll draw them sort of similar. I mean, if you go back up here and look, if you look at the left-tailed test here and the left-tailed test here, they look similar. They're actually not. They're similar, but they're not the same. And that gets to the differences. So the classical method, hold on one sec. There we go. Let's contrast them. All right, so the classical method uses alpha as the area in the tail, if it's two-tailed, right? And z sub alpha, right? The p-value method uses the p-value as the area in the tail and z sub 0. Oops, I just changed the symbols there so it looks more polished. All right, so that's one of the big differences. The pictures look similar, but they're not the same, right? But not the same. They both will look like left-tailed, but they're not the same numbers.